This is Astronomy Daily Live for the 8th of July, 2018. And it is 2:01 UTC on the 8th of July, 2018. So, hey, everybody. Hope everybody's doing well out there. Welcome to those who are new, coming in for the first time, maybe not able to see this live because of what time it actually is in your location. In my location, I'm in southeastern Arizona, United States, and I'm on Mountain Standard Time. Cheers. Mm. Let me get the usual things taken care of here. Gotta stop that. Gotta stop that. Come on. Starting to slow down a little bit. Okay, there it goes. Okay, now I can pop open my chat. Okay. All right. Now we're there. I can actually go on a smartphone over here, Galaxy S7, and pop open that so I can see that I am live-ish. A little laggy tonight, maybe. A little bit laggy. Let's see. Pretty laggy. Okay. Yeah, there's quite a lag there. There's probably I want to say like 20 seconds or so. So, all right. Well, you'll have to put up with it, just like I will. So yeah, hope everybody's doing well. Hello to those who are new. If you think you like this, make sure to subscribe. You can hit the that notification bell, and that will alert you to when I'm going to be going on live. But it's every day at 2 hours UTC, every single day. So yeah, and that's why we're here now, because it is 2:04 UTC, and this is just a fun, casual get together of friends to share what I assume is just a common passion for the science of astronomy. Boy, my voice is raspy tonight. Andy Cowley checking in from the UK. Wow, it's like 3:04 a.m. there. So good morning. Thanks for stopping in. Greatly appreciate it. Hope everything's well with you. Everything's good here. A good, nice sunset going on. We got a few clouds around. It's monsoon's going to start kicking up again pretty soon. So, but yeah, tonight I don't know if my voice is going to last or not. We'll see. Cheers. As I've said, I mean, I don't. The only part that isn't really like reality is me talking this much, because I'm a really quiet dude, and I would much rather listen. Um, but so yeah, I mean, what you're hearing with this is just me sort of thinking out loud. So it's just, I mean, I'm, yeah, I'm usually not going to sit here and speak out loud. Um, uh, the only time that I do that is when I'm writing code. When I'm writing code, I'm talking out loud quite a bit, quite a bit. So, and I don't think that that's too unusual. Um, but then when I'm working on some kind of a problem, either a programming problem or uh, data analysis problem, or whatever it is, I will definitely be talking out loud there as well. But usually, uh, I'm definitely not ever talking as much as this. And I think I haven't done an analysis. Uh, um, well, thanks, Andy. Thanks, Andy. I appreciate that. Spread the word. Spread the word. I, if I get a modest response from like Europe and Africa, um, then it is definitely not outside of the realm of possibilities that I will do this at another time as well at 14 hours UTC. So that would put that with you at least right now, 3 o'clock in the afternoon, which may be a more convenient time. So, and for me, that's not really any kind of problem. So, um, if I were doing this twice a day, though, probably be shorter uh, shorter episodes, probably, probably. Um, Maybe not. I don't know. Yeah, but I would sort of plan on shorter episodes, like half hour, uh, instead of I mean, I plan on these live streams being about an hour or so, and it looks like I usually go over by about between 10 and 20 minutes or so. So yeah, there's always interesting things to talk about. If it isn't life things, it's astronomical things or scientific things, and so yeah. So glad you could join me anytime. But as I said, if given the right kind of incentive, I could definitely do a 14-hour UTC uh, live stream for sure, for sure. That would be pretty easy, pretty easy. All right, well, cool. I I wanted to check in on Hayabusa and Ryugu, Ryugu, however you pronounce it, the asteroid that it's next to here. I noticed that there was an update a little while ago. I'm going to share my screen here and we'll go over, we'll make a new Hayabusa 2. It'd be 20 kilometers. 20 kilometers. So stereo image of asteroid Ryugu. So Brian May, the famous Brian May from Queen, uh, has created a stereoscopic image of Ryugu to view the asteroid in 3 dimensions. So Brian May from Queen did that. That's pretty cool. You're gonna have to pull out your red and blue glasses in order to see in order to see them. I've got some. I'll show you what they look like. I don't know if you have any idea what I'm talking about or not, but these are really dusty. But one of them is red. That one's red and that one's blue. See? Red and blue. Red, blue. So you're supposed to look at these images with the red and the blue. Come on. So I'm going to share my screen again. And hide that. And go over here and let's take a look at through the glasses, right? I'm going to put you down to look through these. See, so there's Brian May. There he is. On the left. There's the stereoscopic view, and there it is. So let's put on the glasses. I'm going to put you down. I'm going to look at it. Okay, I've looked at it. That's about it. Video from Brian May demonstrating how to view the asteroid Ryugu in 3 dimensions. Well, we already know how to do that. So there you go. There's some pretty new data there, right? 2 exposures, 13 minutes apart. You can see the rotation, right? This guy's sort of facing us a little bit more than this guy. And this funny looking thing up here, look at it, looks different over here. And here's that shiny part right there. You can see a little bit more of it there. So yeah, very cool. So that's Hayabusa. I think they're going to take their time, right? They're going to take their time mapping this thing out, seeing where a good place to land and to shoot is. Going to be shooting some projectiles into this thing. See what it does. I think they're going to be in for a little bit of a surprise. What that is? Oh, I don't know. I don't know. But I think they'll be surprised. Okay, so stop sharing. I think let's do another cheers. Yeah, Bobby, you got to get some, dude. They are you know they're awesome. They're very very awesome, and yeah, you can definitely tell that everything is 3D when you wear those. So cheers. Yeah, yeah. You can find yourself a pair. I think you can probably buy them, right? Now this is interesting. I didn't. I don't. Yeah, see, I did not. I don't remember where I got these. I don't remember where I got these, but apparently I got them somewhere around February 1st, 2009. I don't remember why I got these. Maybe we went to some kind of movie theater. Maybe I don't know. I don't know. That's a gone memory. Gone. So yeah, it's actually one of those things, uh, one of those funny things that I keep usually within arm's reach, right? I've got books up above here, and books over here, and you can see all the books back there, right? And there's more books over here, and then I have books in another room, so I have a lot of books. Um, and what I'll do is I'll fold them up like that, right? And I'll just stick them in between two books in the shelf, and that's where they'll sit. And I have various other items in between books, um, mostly like business cards, but I've got like a bookmark. I don't know why that's there. Pictures, yeah. Anyway, yeah, they're just red and blue as far as I know. Yeah. I'll bet you can find those on eBay. I'll bet. I'll bet. But it does allow you to, sort of get a little sense of depth there. Um, yeah, yeah, not too bad. Not too bad. So I guess I guess the the problem with astronomy, right, is that there's so much. I usually have sort of uh, the opposite problem when it comes to subject matter. It's not that I can't think of anything. It's that I'm thinking of too much, and it's like, how do I narrow it down, right? Because I don't want to repeat too frequently. I want to be able to have a little bit of variety over the course of days, not necessarily really have a schedule, but have some kind of regularity, some kind of like object of the day, or what I'm thinking of doing today is a constellation of the day. um, So, I think as long as I'm not doing that like every day, um, then it probably stays pretty fresh. And, over the course of a year, we might get through, I don't know, half of them, maybe a little bit more than half of them. Um, yeah, one a week, one or two a week, maybe. So, yeah, we might be able to get through all the constellations um, over the course of a year, maybe. But I think I mean, this live stream is to talk astronomical things, and a really great way is to have sort of this umbrella thing. In this case, being constellation, um, and then within that concept, there's a lot of other things astronomical to talk about. Catherine 313, hey, nice to see you in the chat. Hope all is well. So yeah, let's do a constellation of the day. So I'm going to go over to going on my Linux machine here, and I'm going to pull up my list of constellations. Now, these are the 88 constellations identified by the International Astronomical Union. Um, and they've defined all the boundaries and I guess primarily just the boundaries. Um, and so I've got an alphabetical list of those 88 constellations. So what we're going to do is we're going to go back to random.org. And by the way, I showed episode 4 on my Rabbit room, um, episode 4 of Cosmos, and I gotta say that is one of my more favorite ones. Um, Carl Sagan, is an incredibly um, eloquent. All right, I don't know why that's doing that. Random.org. And I'm going to choose an integer between 1 and 88. Now, it was pointed out to me by a regular viewer of this live stream that there are there are 30. I think he said 36 northern constellations, and the remainder, what is that? 52, 88 minus 36. Yeah, there are 52 southern constellations. So there's a bigger chance that this random um, number generator is going to choose a southern hemisphere constellation. So which puts us to somewhat of a disadvantage in the northern um, hemisphere, because we may not be able to see it. But the reason why we do these constellations of the day isn't necessarily just to be able to go out and see it. As I said, it provides a platform for discussing any variety of topics, of which are associated with this constellation, right? It can be a star, it can be a variable star, it can be a binary star, a galaxy, a cluster, whatever, right? So let's see which constellation we're going to focus on here. Ready? Here we go. So number 19. So I'm going to go over to my list and go down to number 19. It's Centaurus. Centaurus is the constellation of the day. Woohoo! Well, if you don't already know, there's a lot of what we humans consider to be pretty interesting and exciting about Centaurus, right? I guess probably number one on most people's minds would be the fact that the closest stars to us, other than our sun, but the closest stars to our solar system are both located in the constellation of Centaurus. And of course, we're talking about Proxima Centauri and Alpha Centauri. So that's very cool. There's also a very, very well known and huge and beautiful globular cluster called Omega Centauri. And Omega Centauri is very awesome as well, right? Um, but you know what? You've probably heard those names quite a bit. So let's find out. Let's go over to Centaurus, the constellation, and see if there's anything else interesting that you can sort of be aware of in that constellation. Centaurus constellation. So it's a pretty big constellation. Let's take a look here. Okay, well, it's not incredibly huge. Let's see, hold on. I just want to see if I can make this a little bit bigger. Ah, oh man, it backed me way up there. That's as big as it wants to be. Okay. Well, so we're going from a right ascension of 11 hours all the way over to a right ascension of 15 hours. So that's 4 hours of right ascension. And we're going from about -60, right? Here's -50, here's -60, here's 65. Here's -65 all the way up to -30. So that's 35 degrees of declination and 4 hours of right ascension, which is it's about 15 degrees per hour at the equator. So it doesn't translate exactly right, but just for argument's sake, right? 4 times 15 is uh, uh, 4 times 2 is 30, 45, 60. So it's not quite that big. It's about, well, as you can sort of see from the picture, it's sort of squarish. Um, yeah, I would say 35 by 35 at that declination. And as you can see, alpha and beta are marked there. And as you can also see, Crooks, the Southern Cross, is right there as well. So there's some really bright stars next to one another uh, in the sky down there. Very cool. And Omega Centauri, where's Omega? I think it's 51. I think it's 5139. I think that's Omega Centauri right there. I think. I don't see it anywhere else because it is an NGC object as well. I just thought that they would have marked it as Omega, but I'm not seeing Omega anywhere else. So I'm going to assume that that is probably it. So yeah, so there it is in the sky. You folks in the south can definitely see that. I can see Omega Centauri from my latitude, but I'm pretty low latitude. I'm 32 degrees north, so I'm pretty low latitude, so I can see pretty far south. Right, I can see. Um, let's see, 30, 90, 32 minus 90. I can see to -58. So I cannot see Alpha Centauri. It is just below my horizon. You see that? Because Alpha Centauri here is it's like at -61 or 62. And my horizon is -58. So my horizon is like right there. So I can't see Alpha or Beta. I can see the top star in the Southern Cross. Now that I did not know, but it's going to be like 1 degree above the horizon. It's going to be insanely low. I will never, I will probably never see that, although I should try. I don't know if my horizon is that flat. Yeah, I don't know. I don't know. Interesting. Interesting that I should be able to see the top star, the most northern star in the Southern Cross. But yeah, so 5139 is out there. But as I said, let's look and see if there's anything else, because those are, you know, sorry for the pun, but those are sort of the stars of the show, right? So let's look and see um, what else we have in Centaurus. I mean, it's a pretty big constellation, right? So let's go back to the Wikipedia page and see. Yeah, one of the largest constellations. It says right there. Let's see. Notable stars include Alpha Centauri um, and V766 Centauri, one of the largest stars yet discovered. Constellation also contains Omega Centauri. Yeah. So V766 Centauri. I don't know if I've ever never investigated that before. Several very bright stars. You can sort of see it on its side here. So you can see the Southern Cross through the tree here. But there's Alpha, there's Beta. Omega is going to be up here somewhere. Omega Centauri, blah blah blah. Centaurus is also home to open clusters. So NGC 3766, NGC 5460, Planetary Nebula 3918. Should we look and see if HST has seen any of these? Planetary Nebula sounds interesting. Centaurus is rich in galaxies as well. Holy moly. Okay. Let's look for this planetary 3918. We'll go over to the Hubble archive. Unicorn potato, how are ya? How I hope everything's well. Well, Unicorn, you do have math skills. Believe it or not, you are calculating uh, in what we would call mathematical ways right now as I speak. So yeah, you've got it. You've got it. Yeah, I know about the Control Plus. So yeah, I can do that. Anyway, let's see 3918 NGC 3918 Planetary Nebula. Now, it is very unlikely that the HST has seen this, but let's look anyway. I've been surprised before. Ah, look at that. I can't believe it. Well, we are being super lucky with all of this. I got to tell you. All right, well, let's take a look. Look, we've got three colors too. Oh my God. Can we see these? What does it look like? Oh my God, look at that. Oh my gosh. Uh, sorry, we have to do it. NGC 3918 001. Save. Yeah, it's going to be one of those. So that was at 658. That's the reddest one. Let's go 650. Ooh, that's not very close. Well, whatever. 656 is the next one. Hopefully it's the same field of view. It looks like it is. Looks like it's overexposed, but that's okay because we're gonna hopefully look at the you see what NGC 3918002, and then 502. Oh, it's probably already over here. Okay, so there's 502 for what it's worth. They sort of all look the same, but NGC 39, I'm going to call that 3. Okay, so here we go. Load up GIMP. Yeah, you know, our intro, I hope, I mean, seeing the southern sky would definitely be a thrill for me. I would love to see the Magellanic Clouds. I would love to see the center of the galaxy above me, as opposed to, you know, almost on the horizon. Um, uh, yeah, as I said, you know, it would be a completely foreign sky to me. I would not, I would literally not recognize anything at all. I mean, if the Magellanic Clouds were there, I would probably recognize them, probably. But honestly, I really don't know how big they look, and I don't know how bright they are. Hey there, Bob Dog. We're looking at HST images of NGC 3918. It's a planetary nebula in the constellation of Centaurus, which is our constellation of the day. So I'm just loading up 3 different images that were taken at 3 different wavelengths. And I'm going to sort of arbitrarily assign colors to each of them. Oh, downloads. I'm going to arbitrarily assign some colors. All right, so I'm going to put you down just for a second. Okay. So there they are. The first thing I'm going to do is I'm going to change this to an RGB image. And then I'm going to invert all of these. Now the center is going to be overexposed. I mean, it already is. So, you know, we're not gonna worry about that because I'm interested in seeing, and it looks like what these people were interested in seeing was the outer portions. And when we start adding these together, we are going to see outer portions. Ooh. We'll make that screen also. Okay. So let's just go red, green, blue. Okay. And just see what happens here. So let's get a nice bright red. And a nice bright green. and a nice bright blue. Whoop. That blue enough? Okay, so now let's combine these, merge the layers. I don't know why it did that. So I'm going to undo. Okay. Now I'm going to, let's just see what if we can just equalize and see what happens. Okay, that's too much. That's a little too much. Let's white balance. Nope, that really didn't do much. So if the auto things don't give me any satisfaction, then I switch to brightness and contrast. Yeah, I'm not seeing anything too incredibly interesting there. It's a little small and a little overexposed. And well, are things lined up? Oh, that actually looks better than most. Um, Cancel that. Let's undo the merging. Let's see if we can. Don't really see that changing very much. Oh, there it goes. Yeah, I don't know. I mean, that's not bad, right? It's pretty amazing, amazing looking. Yeah, it'd be nice if that was turned down a little bit. Nope, that's the wrong way. Want let's see if this gives me any satisfaction. Not much. Gotta say, it's not giving me much, but that's pretty nice though. Can't complain about that. There are others, right? There's this one. There's this set, which were taken 8 years before. So yeah, just a different view, overexposed again, but lots of amazing detail in there though. You know, 502. Yeah, that's pretty amazing. Amazing detail. 555. Pretty awesome. So yeah, they've been looking at this for quite a while. Look at that. It goes all the way back to WIFPIC, 1992. That's amazing. Here's one from 1993. But there's WIFPIC 2, the first WIFPIC 2 image of NGC 3918. Planetary nebula. So the at least how the current thinking on these things go is that this is one of the end states of a star. Most likely in the center of this very complex structure is a like a white dwarf star, about maybe half the mass of the sun and about the size of the Earth. So very, very small, but very, very bright. Well, not incredibly bright, but hot, quite hot. Surface temperatures can be around 20,000 degrees, 30,000 degrees, up to 80,000 degrees. So pretty hot. But this, as the story goes, this is the sort of the outer shells of a star that has gone into a white dwarf phase, and part of that phase is a little I don't know if you'd call it an explosion or not, but it's definitely an outward thrust, and so all um, uh, yeah, so all the material in sort of the outer atmosphere of this star has been blown off, and you get interesting structures here that seem to indicate a pole, right? And maybe a rotation vector. Don't know. So if HST images are in black and white, um, yeah. So how that works, Bobby, right, is that the the CCD camera is is sensitive to all light, and um, depending on what wavelength, um, the camera has a different sensitivity, but it's generally sensitive to at least all visible wavelengths of light. So what they do is they put a filter in front of the camera, which blocks out all light except for um, maybe a relatively narrow band of light, um, and that's what this number is, right? This is the wavelength of light in angstroms that this filter is centered on. Now we don't know how wide these are, but my guess is that they're relatively wide, not maybe incredibly wide, maybe a couple hundred angstroms, maybe 10% of that, something like that. Um, so they choose different filters to specify what wavelengths of light they want to expose onto the CCD camera. What you'll get is, uh, the red stuff will show up as a certain grayscale, like a grayscale of red, right? Um, and then you can choose, right, what colors you want. So I mean, and that's why I say, color doesn't really exist. Color is something that happens inside of our heads. Um, what it's all that we really detect is differences in frequencies. So yeah, the actual information, the actual data is grayscale, and it's only when that information goes into our brains that it turns into a color. Yeah. So when we collect this kind of data on a CCD camera and get this grayscale, we can assign a color, any color we want. It doesn't matter. Okay. I did red, green, and blue. I can do, I mean, it doesn't matter, right? I can change this to a, whoop. I can change this to, whatever. Let's look for a yellow. There's a nice yellow. Brighten that up. Yellow. And I can show you that it's yellow by turning off these other ones. There it is. So now it's yellow, green, and blue. So we can assign any color we want. The closer that we assign that color to what it actually looks like to the human eye, then they call that true color, right? But there really is no true color when it comes to at least digital photography. Um, there's always false color, always false color. It's all false color, but we can get pretty close to true color. Close enough that you're not going to tell, right? Except that that it actually is still false color. So let's take a look and see what Sinbad has on this. So I'd like to know where it is. So 3918, that's what we're after still? Yeah. Oh, okay. Well, there's a picture of it. Pretty cool looking. Looks like an HST image. Nicknamed the Blue Planetary. Easily visible through small telescopes. Okay, so NGC 3918. Planetary nebula. So 11 hours, 50 minutes. Got our map back up here. So 11 hours, 50 minutes is really, really close to over here. And then we're at negative 5710. So negative 5710. So that puts it right about there. So yeah, it's actually not something that's on this particular map, but that's where it would be, right? 57. Here's negative 50. Here's negative 60. So here's negative 57 and 1150. Here's 11. Here's 1130, 1145, 1150. So yeah, we're right about there, something like that. So actually closer to Crooks than it is to Alpha and Beta Centauri. So that's pretty cool. And it's pretty bright. A V magnitude, which is using a V filter, is magnitude 8.5. So yeah, that's pretty darn bright. In fact, in the digital sky survey, you see it's just a overexposed bright blue blob. Looks like it's moving towards us at 16.4 kilometers per second. Bunch of different names, different catalogs. Quite a few references. Wow, 354. That's pretty awesome. There's a distance. Let's see. So 1,639 parsecs. So a parsec is 3.26 light years. So 1639. So 5,300 light years away. 5,300 light years away. So pretty far. You know, that's not nearby. It's not, you know, it's not intensely far away, but yeah, 5,300 light years. Yeah, that's pretty far. Got some observing logs here. Let's see if there's any. I'm always up for you know, interesting pictures. Sometimes we just get spectra. Time we're not getting much of anything at all. Postcard has not been produced for this data. Okay then. 918. Let's look at this one. So that's a spectrum taken at, so these are in microns. So this is definitely into the thermal infrared. So they're actually looking at the actual heat from this. And we have these emission lines, which are molecules or atoms, probably atoms, that are emitting light at these wavelengths, and don't know exactly which is which. This is just the data, right? But I would say pretty much every wiggle on here counts for something. Even this big wide thing here, that is even um, going to tell these astronomers something, right? So even the shape, all of it. I suspect that the different colors are just different detectors that are looking in different wavelength bands. So that's pretty cool. Looks like these are probably all spectra. Oh, there's a flux density, which is almost like a spectrum. So again, we're seeing emission. We're seeing emission lines here. These are just plotted in a different way, so they're just little boxes as opposed to lines. I don't know why they would do that, but whatever. See, I don't know. It says image. Don't quite know what it's going to show us here. Yeah. What false color does more than anything else is that and the only real value scientifically is that using false color imaging, you can highlight certain things that you might not otherwise see. So it's a good thing for sure. Oh, I think I just killed it. Get it back. Come on, Sinbad. So let's look at these references really quick. Get out of here. I'm not going to look at them all. Too many. Expansion patterns and parallaxes for planetary nebulae. Brand new paper. Ooh, we got to look. So, well, let's pull up the paper and we can read the abstract there. Go over to ADS. Should be able to pull the PDF. Don't know if you all noticed or not, but on my Discord server, I posted some things about accessing alternative means of accessing scientific papers. There's a few ways, and I agree with them all. Protected article. Oh, come on. Are you kidding me? Oh, you got to be kidding me. Can't see the paper? Oh, come on. Give me a break. Let's see if we can find this. Oh, no, I don't know why it does that. Oh, that. telling and it's going to some weird. Aha! There it is. Take a look at this and then get on out of here. Whoop. Is that the same one? Oh, it's not the same one. Expansion patterns. Oh, okay. No, that's not the right one. Oh, you mean they don't have it? Oh man. Oh man. Okay. Well, that was a bomb. Sometimes you get a bomb. Makes me mad. We don't have access to papers that we pay for. That would have been an interesting one too, I think. And the imprints of last jets and core collapse supernovae. Archive is the bomb. Atlas of monochromatic images of planetary nebulae. We can look at a bunch of grayscale images. Just for you, Arinstro, just for you. Usually there's an archive link right here. Yeah, see, there it is. Dun, 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 dun. It's coming up. It was a little bit laggy tonight, so sorry about that. I have very little control over that. So we present an atlas of more than 100 original images of planetary nebulae. These images were taken in a narrow band filter centered on the nebular emission of the nitrogen 2 during several observing campaigns using two moderate aperture telescopes, both in Argentina. The data provided by this atlas represent one of the most extensive image surveys of planetary nebulae in nitrogen 2. So that's singly ionized nitrogen. So we compare the new images with those available in the literature and briefly describe in all cases in which our N2 images reveal new and interesting structures. So they talk about how they collected their data, what wavelength band they used, telescopes that they used. So, moderately sized, 1.5 meter, 2 meter, the kind of CCD camera, central wavelength, band pass, all in angstroms, right? So very narrow, narrow. limited magnitude. Yeah, yeah. That's what I like to see. Image reduction was performed using standard procedures within IRAF. Image reduction and analysis facility. So yeah, that's just all the parameters that were used to make these observations. I want to see pictures though. And they got all these notes on each one. Holy moly. What are we in for here? Atlas of monochromatic images is presented in figures 3 to 20. In all the images, we tried different brightness and contrast levels to emphasize the most interesting features of each object. A logarithmic scale is indicated with an L. So yeah, sometimes it's best to uh, you know present these images on a logarithmic scale rather than a linear scale, for sure. All right, let's look. Here we go. We're going to look at how many are there? How many are there? I thought they said more than 100. Okay, let's look at them. Here we go. All planetary nebulae. I don't know if these are on the same scale or not. I guess they probably are. Looks like a big bright star. But look at that one. That's interesting. Very interesting. Huh. Oh, that's an interesting one, isn't it? Hmm. Let's see if we can find 3918, right? It's probably, I don't know if it's going to, is it going to be in here? Oh, we should probably look for that, huh? There it is. So there it is. That's 3918, at least in this catalog. Wow. That's terrible looking. Very bright, right? It's overexposed. Overexposed for sure. Are there any more? Oh, there is another reference. Okay, just showing the position and some observing characteristics there. How many did they do? Let's see, 108. 108. What's this down here? It's a little weird to have one way down there, isn't it? I want to look at some more of these. Okay, so we'll get rid of that. These are pretty cool. All planetary nebulae. Wow, there's a lot of action there. This is kind of weird looking too. They're all weird looking. That's what makes them so interesting. I don't know what's going on there. If that's overexposure, I want to say that that's overexposure, that they've just eliminated those pixels. Saturation, you know. Oh, lost my Linux screen. Can't see the chat. There we go. So as you can see, uh, our instro, even here, they've colored them, right? So yes, this is monochromatic, but they've given them all this red orangey color. Don't know if that's the central star or if that would be like a foreground or background star. Hard to tell. Ooh, that's pretty amazing looking. Look at that. Huh. Which one is that? PHR 0905 minus 4753. Hmm. Well, at least we know where it is in the sky. Pretty interesting looking. Look at that weird structure there. I don't think I've ever looked at this many planetary nebulae before. Yeah, and they said in the paper, that they sort of stretch these, to bring out the best. Pretty awesome. Ooh, that's nice. That's probably not real. That's probably some kind of a thing on the camera, hair or something. So there's 3918. Just too bright. Wow, look at that. What a mess. Look at this. It's got a arc there of some sort. Wow, look at that one. Wow. What is that one called? VBRC5. VBRC5. Yeah, I know. I'm going long. Sorry. Not a chance. Not a chance. Nope. No coordinates returned. So it wasn't able to resolve that name. Poo. Anyway, that's pretty cool looking. Just the end, one of the end states of stars. Our sun is going to do this. So 5 billion years from now, 6 billion. This is what our solar system will look like to somebody else outside. Something like this. Who knows? Yep, this is how our solar system is going to end up. Not a bad way to go, I guess. Going to be very pretty for a long, long, long time. Hope somebody enjoys it, because we will all be there. That's it. I don't know why there's no pictures here. That's figure 20 though, so that's the end of the pictures. So all right, I see. Since that's the end of the pictures, let's make it the end of the live stream. All right. So take care, everybody. I will see you again tomorrow, 2 hours UTC, and yeah, spread the word. See if you can cajole somebody into watching. Um, all right. Take care, everybody. Hit the thumbs up, subscribe, all that jazz, share. All right. Take care. I will see you tomorrow on the spin. Bye.